is all about identifying features on Imagery. So if you can be able to bring them out, then later it will be much easier to carry out, supervised classification and what have you. So I will share my screen. Just a minute. Yeah, so I've shared my screen. Just a minute. Okay, so we are going to look into accessing Imagery, and before we access this Imagery, we need to select an AOI that will give us the area of interest that we need our Imagery from. So for this particular task, I'm going to open QGIS. Just a minute. Okay. So that's QGIS. Okay, that's QGIS. I'm going to load a particular image, a particular data source. This data source, I got it from, let me show you the link. Yeah, I got it from the regional center. If you, for example, you need shapefiles, if you're working on Kenyan data sets and you need shapefiles, then you can be able to get Kenya County shapefiles. There are quite a number of sources of these Kenya County shapefiles. So I will be using the ones from the Regional Center for Mapping and Resource Development. So just a minute. I think I had it somewhere. Yeah, so you can just download the layer that you need and select the particular type. So we'll be working with a zipped shapefile. So that's what I downloaded. Okay, so after getting our county, if we open and look at the attributes, we'll see that we have the county under the county name. There are 47 counties, but we will not be able to use this data as it is. And I've looked at a couple of data sources and I've realized that they have this issue for Kenya, that is, if you go to the properties, you realize that they are multi-polygon. If they are multi-polygon, it's going to be an issue later when you're using GEE to extract our imagery. We need to convert this geometry type to only polygon. So to do that, we go to a particular tool in QGIS called multi-part to single part. And then after here, we select our county, and then we can create a temporary layer. And then we run it. Before we run it, let me show you something. The reason I'm doing that is because you see in this coastal area of Kenya, we have some islands. So this is the issue that these particular islands will bring issues later when it comes to extracting our image, because the polygon needs to be fully closed. So we'll have to convert all of these into individual polygons. So that's why I need the multi-part to single part. And then I run it. Yeah. So I want you to pay close attention to this image. When I click a particular, when I select, I'm sorry. when I select even an island, it selects the entire polygon. But after getting the single part, when I select, sorry, just a minute, it only selects the island. So it will be possible for us to extract AOIs, to extract imagery from, for example, this particular island and this particular mainland. So I'll leave that for now. And then after that, we will export it as a GeoJSON, save feature as. So we'll give it the name. So I'd already exported it. I call it Kenyan counties. So let me load. Vector. Sorry, layer, add vector layer. Just a minute. Yeah, so we add it, close. Yeah, so we have our GeoJSON layer. If you notice, if we go to its properties, yeah, it's a polygon layer. So we can be able to utilize this in GEE to access our imagery. To be this particular file will act as an AOI to access our imagery. Once we have done that, the next step is to export this GeoJSON. Let me show you the file that it is in. Just a minute. Yeah, so I will export this particular file into my Google Drive. Yeah, so here it is. I just sorry. Yeah, so I just copied it directly to my Google Drive, so that when I'm working with Google Earth Engine, when I'm working with the Jupyter notebooks, I'll be able to connect to this particular drive. Okay, so that's done. So after doing that, we go to our notebook. Just a minute. Okay, so I will close this. Then I'll go to our notebook. Yeah, so once we have our data, we now have to create a Jupyter notebook to load our data, and also to load the files that we'll need, and also to create the functions and what have you that will allow us to access the imagery. So I'll be downloading a Sentinel-2A data. So first of all, we'll have to install some libraries, the GeoPandas. It will be crucial for a visualization of the image, the GeoJSON to load our GeoJSON file. And then right now we might not use rasterio, but Gmaps is important. The TQDM will help us, will help us know, for example, when you're doing a particular process, the time that it will take to complete this particular process. So, so I have to install it. I think everything is right. But in this particular session, we will not be able to, just a minute, we will not be able to use the TQDM. Okay, so let's see. Okay, we can ignore these errors, even though some of these files will be incompatible. We'll be able to use them in this exercise. Then after that, we can do the setup, and then we can mount our drive. So I'll like have to mount it. Yeah, so it has already been mounted, and then we'll authenticate our Earth engine, and then you'll have to use my account. Yeah, allow. Then I'll copy this code and bring it over here. Yeah, then authenticate it. Now I'll fetch my Nairobi, sorry, let me just edit this part. It was not Nairobi, it was Kenya. Yeah, so if you had saved it in your Google Drive, then you'll be able to access it after mounting your Google Drive. Okay. Okay, that's done. Yeah, so we have our Kenyan counties. Now we'll put the path of our GeoJSON. For me, this was the particular path to the Kenyan counties GeoJSON that will serve as an AOI to download the imagery. And then, oh wait, let me run it so that it can pick it up. Okay. And then we'll visualize the counties, the GPDs, the GeoPandas, and it will allow us to read the GeoJSON file. And then we'll visualize three rows of this file. Yeah, so we can visualize the object ID, the area, the county, and the county name. This is very important. We'll utilize this later. And you can see the geometry is a polygon. If the geometry was a multi-polygon, then it will be hard for us to access our imagery later on. We need closed polygons to act as the AOI for extracting the image. Yeah, and then now we can visualize. Then we can be able to visualize our data. Okay, the legend is a bit big. Just a minute, let me remove this legend. See how it. Yeah, so 1 minute, let's see. Yeah, so as you can see, that's our data. We'll need one of these areas. We'll need one of these areas to extract our image, and we'll be using Nairobi. I'll just return this. Yeah, so that's that. And then now we need to now generate our Sentinel-2A. We'll have to define a function that will generate the image, and we'll be using Copernicus data set, and our date will be using any image whose cloud cover, whose cloud percentage is less than 10 or anything less than 10. And yes, I will try to share the notebooks. I will try to share the notebooks. If, for example, you are participating in the Kenya Red Cross Omdena chapter for assessing flooding, I will definitely share the notebooks. Yeah, Copernicus is, it's like a program of the European Space Agency, and it is the one that is, kind of, just a minute. So it kind of monitors. So the Copernicus program helps to send all these particular satellites. It's a program of the European Union, and it kind of administers the Sentinel satellites and what have you. So it's similar to NASA, if I'm not wrong. Okay. Yeah, so we'll have a Copernicus project to get our Sentinel-2A, and then it will give us an image from January last year to December last year. And then these are the bands, but you can change these particular bands to specify the bands that you will need. And then, yeah, just a minute. So this is just a function to generate the Sentinel-2 image. And then, yeah, this will decide which particular bands we'll be able to access. If we only want the RGB, then we'll put RGB in our particular function over here, and we'll only be able to access RGB. So after that, now we are trying now to get our polygon from, the entire Kenyan polygon. We are trying to get a particular area, and our county name that we are going to use is called Nairobi. 1 minute. Yeah, so after doing that, we are going to, just a minute. Yeah, so let's go back. We are going to use this later. I've just commented them out because we'll use it for the pre-processing. Right now, I will want us just to visualize the image and see how it is. So after generating our image, we'll come over here and write this particular function to be able to visualize our RGB. Band 4 is red, band 3 is band 4 is red, band 3 is blue, RGB green, and then band 2 is blue. From this particular, just a minute. Yeah. So it's also very important to know the bands of the satellite that you want to use. The bands are usually different for maybe Landsat and Sentinel. So in our particular case, if you want to visualize the RGB, we'll use band 4, band 3, and band 2 RGB. And then later, we'll also want to use the near-infrared, which is band 8. And then we'll also want to use the shortwave infrared 1 and shortwave infrared 2. These are the 4 bands that we'll use for this particular exercise. So, okay, so this is our red, green, and blue. So you're going to visualize it. And then the function for visualizing it is this. So you have to center your map using the centroid that was generated over here. There's a centroid that we generated. And then, and then we visualize our imagery, and then we add our geometry, and then we visualize the map, if you can see it. So this is and it has no cloud cover, which is a good thing. This is rarely the case. Let me remove the geometry, and then you can see for the whole of Nairobi at 10 meters resolution. Let me see if I can remove the Google Maps. Okay, so if you have extracted your image, let me just do a recap. You need this particular function. I'll be able to share this function with you guys. You need this function to generate the image. And then it depends if you want only to extract, even if you want to extract every image, it's possible to extract, because in this function, I extracted all of these particular bands. And then when it came to visualization, I only visualized, as you can see, I only visualized the 3. So it's possible to extract all the bands. I think there are 13 bands. It's possible to extract all the bands. And when it comes to visualization, you can visualize only 3 bands. So after downloading your image and visualizing it, you might want to download it from kind of move it into your personal local disk. So in that case, you have to export it. So I'll export this particular image to my Google Drive, and then I'll download it from that point. So the next stage is to export the image to the local Google Drive. So you'll need a function. And these functions are usually given by the Google Earth Engine team. We have a lot of API documentation that when you go read it, you'll be able to see what all these functions do. So you'll just pick this particular API and realize that for this particular function, you need This is what you really need. Once you need this, you just specify your variables. This is the coordinate reference system. I think this is WGS, and then the file format, and then and then after downloading it, you'll be able to create a folder. This folder will be created automatically, and you'll be able to see your imagery. So if I go to my drive, just a minute. I don't know if I still have to. I need just 1 minute. Okay, can always open another one. So if I go to my drive, I'll realize that this folder has been created with the imagery. So I downloaded this particular imagery, and then after downloading it, let me show you how it looks using QGIS. But the QGIS is a very important open source GIS software, and it's good to utilize it even when you're using Python and what have you, to just check to see whether your results are okay. So let me load my raster layer. Yeah, here it is. Okay, so let me just. So when you load it, you realize that it does not look good. The reason for this is the data is saved as an 16-bit integer, but normally our computers and most of our systems deal with the 8-bit integer. So we'll have to convert this data form into an 8-bit. Thankfully, when you're working with Google Earth Engine, this is done kind of automatically. There's a way. Just a minute. Yeah. Okay, just a minute. Sorry. Some of these folders are. Okay, I don't think we need this. Yeah, here it is. I think I don't need this too. So when you're working with Google Drive, the reason why we are able to visualize a very good output, we cut some data. Let me say that we cut some data so that we can visualize it. You see the minimum and the maximum. So we try to cut off some data so that we can at least visualize it in a good and a clear way. So we need to see if we can do this offline after downloading your image. So let me just show you something. When you go to properties, you will see that it's a GeoTIFF, yes, but the data type is a 16-bit unsigned integer. This is not good when you're working, when you load an image. You need to at least ensure that your image stretches to 255 characters. That is about that's about 8-bit of data. So we need to convert this, and you can see we have like 4 bands. We have the R, the G, the B, and the near infrared. Yes, for this case, we have the four bands. So in this particular case, there's a particular tool called Translate. Yeah. So with the Translate tool, we can be able to load our imagery. Oh, sorry. Yeah, this one. So once we have our imagery, it becomes possible for us to convert it into a byte. 8 bits is equals to 1 byte. And then let me run it. Okay, let's create a. Okay, just a minute. Yeah, so let's do it again. We have the layer, we have everything, and then the only thing here you have to change is the byte when you run it. Then we close it. I think it's because I'm using another screen. Let me remove it again. Okay, I think I will run it again and see. Where's the byte? Yeah, and then let me save it. Let me save it to another file so that I can load it. Save to file. Yeah, let me write a new folder. Custom. Okay. Yeah, so let me run it. Okay, close it. Okay, remove. And then let me load it. Layer. I lost a layer. Then this is the 8-bit data. Whoa, why is it not showing? Okay, there was something. Okay, there was one that I did. Let me bring it. Let me just bring it. Yeah, there's one that I did earlier, and this is now how it's supposed to look. I don't know why it's not working now. So if we go to the properties, we'll be able to see that it's, okay, no, not this one. Yeah, for this one. If we go to the properties, you'll see that it's an 8-bit unsigned integer. That's why we are able to visualize it really well on our screen. So it has about 255, you see, 255. That's 0 to 255 characters, which can be accommodated well by our screen monitors. But when you look at the one that we got directly from Google Earth Engine, look at the properties, look at the maximum. This is really a lot of data that the color guns in the computer screen is not able to accommodate all of this imagery, and it's 16-bit. Okay. Yeah, so we'll leave this at that and then come to just a minute. Yeah, now come to the processing bit. I hope up to this point, when it comes to downloading the imagery and also using it in your local drive, I hope that will be clear. And when you download it and you have certain issue with the display, there's a tool in which you can be able to use this particular tool to be able to visualize your data in the right way. So apart from that, apart from downloading our imagery, now we are going to look at pre-processing it. So I'm going to uncomment some code over here. So what you're able to visualize in this particular screen is a true color image of Nairobi. So we are going to try and create for Scala Composites to see if it will help us, identify certain features correctly. So there are some that I did create. Yeah, so, okay. Let us create this one. This particular color composite utilizes the near infrared, the red, and the green band. And it will help us to differ. Okay, if our image had clouds, then when you use this particular combination, you will be able to see the clouds much better and the shadows, because at certain times the shadows and the vegetation, especially the dark vegetation, look very, very similar. So if, for example, you have a cloudy image or you have some vegetation, it will really be crucial for you to try and pre-process it first using this band, so that you can be able to see the shadows and separate the shadows from the dark vegetation. So we are going to use this. Another band that you are going to use is this one, band 12, 11, and 4. This is shortwave infrared 2, shortwave infrared 1, and the red band. Let me just jog your memories again with this Sentinel. Where is it? So many slides. Yeah. So this particular, the second color composite will be made up of these two shortwave infrared bands and the red band. Whereas the first color composite will be made of the infrared, red, and green. So I would like you to really see the difference between the true color, this is the true color, and the two color composites. The two color composites are there to just accentuate our particular features, so that later it will be much easier. For example, if you want to do your classification, or if you want to run your k-means, then especially when it comes to unsupervised classification, you'll really lend a very good hand to the unsupervised classification if you can be able to accentuate certain features. So I'll run this. Okay, wait. I need to also visualize them on the map. So 1 minute. Yeah, so we are visualizing our true color, and now we also want to visualize our color composites and see if we can be able to detect some features that we could not detect on the true color. So I think everything is set. Let us run it. Okay. Let us now come and visualize. Just a minute. Okay. Okay. So the first thing, let's remove this geometry. And then we'll start with this. Let's start with this first color composite. We see if we can be able to visualize things that are not in this original Sentinel imagery. So with this other one, when it comes to the road, we're able to see the road really, really well. And also you see this part, but this will also be another feature that we'll explore when we're looking at the indices, because when you look at the Sentinel imagery, you might think that it's like some vegetation or some garden or a farm, but you'll realize that it is not, and the use of indices points this out. So when you utilize the color composite with bands 12, 11, and 4, there are certain features that really crop up. If you can see these dark dots, these are probably water surfaces. Even these are probably water surfaces that, just a minute. Let's look at the Sentinel imagery. You see it's actually water, but when you look at it with your own eyes, you cannot be able to tell. But when you're using this color composite, the water surfaces, are accentuated. But this other one does a much better job at accentuating the water surfaces. The one that utilizes band 8, 4, and 3. As you can see, the dark spots on the screen are actually water surfaces that were not that visible. Because if you are looking at the image, it's really rare to identify a water feature. But if we use this color composite, you see we can, even this over here, it's a water. I think it's a swimming pool. Okay, let's see if we can see something else. What about this? Yeah, also this is a water body. So all these dark spots are actually most probably water bodies and water surfaces. I think this can be a sewage facility. I'm not quite sure, but when you look at it from the Sentinel imagery, you might think it's some lush vegetation, but it might be a water treatment or a sewage facility. What else? So the use of this false color enable us to accentuate certain features. So if, for example, you are carrying out your maybe K-means, or if you want to detect water surfaces, as you can see, most of these water surfaces are black. So if you set your pixel values to, if you set your actual, if you set your, for example, your color values to 0, you can be able to actually mask water surfaces from your image. But when you look at the true color, you see it's so hard to tell. But this is some water surface. It's so hard to tell if you're looking at a water surface or you're looking at vegetation, because as you can see, this other area is, vegetation. Let's see some other area that crops up. Yeah. Yeah, and another thing that really crops up is, you can be able to identify your built-up areas. As you can see, the white portions are the built-up areas, the red portions are vegetation. I think this is vegetation. Let's see if it's vegetation. Yeah, it's vegetation. So if, for example, you are coming up with your next algorithm to, classify features based on, a pixel, identity or closeness, then if you first do this for scalar composites, then you'll be able to, help your algorithm to do a much better job. I don't know what this is. Is this water? Okay, there are some that really pop up well, like this muddy patch over here. Yeah, so that's one of it. And then another thing that is really clear, you can be able to, for example, this is an airport. This is an airport. I think this is Jomo Kenyatta International Airport. When you use color composites, the roads, the paved areas really pop out. They really pop out, because if we look at the original, you might really struggle to see it from this particular angle. But if you are using your color composite, they pop up in a certain way, and even the roads. And the good thing is that all these have some color value attached to it. So if you can be able to ascertain the color value, then you'll be able to extract, for example, the roads. You'll be able to extract the vegetation from this color composite. And the best thing to extract from this 843 color composite is the water, because when you look at its value, the pixel is about 0. So if you come up with your code and you create a loop that goes through the entire image and aggregates the pixels whose pixel value is 0, then you'll be able to extract your image. Okay, I'll leave that for now so that we can look at indices. And even if you can, as you can see, there's a purplish color around urban areas. But when you look at the true color image, it becomes a bit harder. Yeah, so we'll leave that color composite. So if, for example, we had cloud cover on this image, you'll be able to tell the difference between the cloud shadow and also the cloud. It will really pop out. It will really pop out, and then you can do the cloud masking, and then you can do the cloud shadow masking, so that it does not interfere with your calculations. So apart from using it, and then just a minute, let me also look at this one. this particular feature really pops out. Again, I feel that it's a sewage facility. I think it's a sewage facility. And then all these are water bodies. All these are water bodies that it might be so hard to identify. You see, it's so hard to identify it until maybe you zoom in, but you can, there's a likelihood of, classifying it as, vegetation. Okay, here it also pops out on the color composite 843. The color composite pops out the road and also the water surfaces. Okay, let's now look at the indices.
Hi, Caleb. May I ask a quick question, please?
Yes, sure.
Actually, I just wanted to know that the color composites, how do you come to know that to use which color composite for roads or which color composites for what? Is it by trial and error, or is it listed somewhere as a guide that you use these color composites to identify these features?
Oh, okay. There are quite a number of studies that have been done. There are quite a number of studies that have been done to try and play around with all of these indices and try and merge different indices together. So there are papers that are out there that give a description of which indices you have to use and what have you. So there are quite a number.
Okay, thanks. That's easy.
Yeah. Yeah.
Hi, I have a question.
Okay.
You initially you said like we can export the images to Google Drive, right? So during that time, is it possible to reduce the resolution and export? Because usually the TIFF images will be very high, right? It occupies more space.
Oh, okay. Yeah, but in this particular, because Nairobi is quite a big area, there's a way in which you can be able to reduce the resolution of your image. But why would you want to reduce your resolution? Because the reason why we are utilizing Sentinel is because of its high resolution. Another option you can use is just tile your image. There's a way in which you can do tiling, and then you can export the tiles differently. Let me show you something. There's a particular project I was working on, and we were able to do the tiling, and then after that you can export the tiles differently and save them. Just a minute, let me show you something that we are working on. Save project. Open recent. I think this one. Okay, yes. As you can see, there's a project that I was working on earlier, and there's a way in which you can be able to come up with these tiles. And then when you create your tile, you can export. Okay, these were very, very small, but you can create bigger ones. And then it will be possible to export each tile separately, because if you reduce your resolution, you are actually degrading the quality of your image. So if there's a way in which you can, you can come up with a tiling system. Okay, this was way too small. This was way too small, but you can come up with much bigger tiles and then export each image as a separate tile.
Yeah,
So
thank you for the classification.
Okay, but it is possible to reduce the resolution of your imagery, but doing that kind of limits your use, because yes, you can be able to reduce the resolution, but again, improving its resolution is something else. You have already lost some data in the process.
Yeah, that makes sense. I got it. Thank you.
Oh, okay. So let me just go to this. Yeah, so now we have utilized the color composites. That's just another way of, all these are pre-processing that you can do to further aid your, classification or any regression or any other processes that you might want to later carry on to get some features from your imagery. So apart from using color composites, another particular thing that you can use. Just a minute. Yeah, apart from using the color composites, we can use indices. Yeah, we can use indices, and I've listed some 2 indices that you can be able to use to see if you can extract certain features. We have the popular Ndvi, Normalized Difference Vegetation Index, and then we have the Normalized Difference Building Index. This one is supposed to extract vegetation from our data set, and this second one is supposed to highlight, buildings and urban structures in our data set. So I will now just and then when it comes to the visualization, oh, sorry. Yeah, so the code, the thing with the code is that there are quite a number of APIs, and if you need to do anything, when you go to the Google Earth Engine API, or there are quite a number of tutorials. The thing is, you just need to know what you want to do, and then how to do it, you'll find a way. You'll find a way of how to do it. So don't mind the coding and everything that goes on with this. As long as you know what you want to achieve from your data, then you'll be good. You'll find a way of doing it. There are quite a lot of ways. There are quite a number of libraries out there that will allow you to do what you want to do, but at least know, what do I want to do with my data? What do I want to get from this data? Once you know the why, the how will ultimately fall into place. So in this particular case, we have our image that, this is the image that we generated from this particular code. And then once we have our image, we'll extract our band 8, which is near infrared, band 4, which is red. And then we'll do the Ndvi calculation, which is the near infrared minus the red band divided by the near infrared plus the red band. Then you can rename it. And then I don't mind this particular one. This is just to show that if the greener it is, we'll give it a color green, because that's 1. And when it's -1, it means then that the area is not does not have vegetation. It will have a gray. And then when you're looking at this other index, it's supposed to highlight urban areas, but there's something that I will show you. It's not a perfect method, because it also highlights other features, but you'll be able to see later. So let's run the code. Yeah, running it. Yeah, so the first thing that we have, okay. So this now is the urban image, the one that is supposed to accentuate our urban areas. But as you can see, it has really, okay, the dark areas are the vegetation. The dark areas are the vegetation. But as you can see, it has also accentuated, it has also brought out the ground. This is because, and this has been an issue with this particular index, it is not able to differentiate between the ground and urban areas, because you see most urban areas are made up of, materials that can also be found on the ground, like for example the clay, bricks and what have you. So the shortwave infrared, oh, okay, that's another thing you can do. You can be able to, there are modules that exist that allow you to calculate the Ndvi, but I just wanted you to see how you can also do it yourself, because all these indices is just a matter of, testing and trying, and maybe you can find another research that has another way of, merging all these indices together, and then you'll know how to do it. So Ndvi is very popular, and there are actually modules out there that will allow you to actually do the Ndvi, but this is how they normally do it, just subtracting the bands and then dividing and then adding the bands. And then after that, you get an indices that actually works very well. So apart from that, so that's the problem with this first index for trying to detect buildings. But when you're looking at it, you can see that at least the ones that are very white indicate buildings. So you can try, if for example you are running an algorithms, you can try to get a scanning algorithm that will try to get certain small pixels and ignore large pixels. So if you're running, let's say, like a neighborhood analysis, you'll be able to set some threshold that use only 5 or 6 pixels that are in a neighborhood, and then you'll be able to extract these small buildings that you have, and then it will ignore much bigger areas. These are all ground. Oh, sorry, just a minute. Okay, these are all ground areas. You can see they're all ground areas. Okay, and then let's look now at the Ndvi. As you can see, the Ndvi is very crucial when it comes to detecting vegetation, and it does a very good job. That's why it's very popular. And let me show you this particular feature, the sewage. With our naked eye, you'll immediately think that this particular feature is maybe some garden or what have you. But when you use the Ndvi index, you can see that it is not classified as vegetation. So this place is not, a vegetation, area. So if you are, for example, only using your Sentinel RGB and using the green to do the classification, then you'll highly be unsuccessful, and it will classify this part as vegetation. So let me see. So as you can see, it does a very good job in classifying, especially large vegetation areas. Yeah. Just a minute. So those are ways that we can use just to improve our data set and prepare it for further, algorithms and further classifications. Because if you were to take, because all classifications are on their own, they are somehow, let me say dumb. So you have to find a way to, trick whatever algorithm you are using to pick the features that you want. Because if you, for example, only use the RGB, then the algorithm will probably look at the color values, the RGB color values, and it will select some features to be, vegetation, and they're not. These other areas are, water. This is a water body. Let me see. Yeah, this is a water data set. Yeah, so I see that the time is almost up. I will, there are so many other indices that you can use even to detect, water and what have you. And I've shown you, like, for example, the full scalar composites that you can use to, for example, detect water bodies, and also the indices that you can use to be able to detect vegetation. So with that, I think I will let Charan take over. And if there are any questions, I'm opening the floor to any question that can be, out there. Thank you.
Hi, if there is a question, you can go ahead and ask.
Caleb, one more thing, that Google authentication that you had given, Google engine, do we compulsorily need to run from Colab, or can we connect it on a local drive also and have it done? Or is
Yeah,
because
yeah. Go on, Mr.
yeah,
Ravat. Go on.
or is it because it is Google Colab, only via Google Colab we have access to the stuff?
Oh, okay. Okay. It is possible to download the Earth Engine, API and utilize it on your desktop. But when it comes to working in a team, if you guys are collaborating, then you might want something that if you test it on the cloud and you send that particular code to somebody else, they'll still be able to use it and without any
Correct.
issue,
Correct.
because our local environments are usually very different, and something might run on your computer, but it might not be able to run on somebody else's computer.
Got it. Got it. Got it. Thanks. Thanks. That's good.
Okay, I can see a question from, okay, let me see. Okay, Douglas, yes. Douglas, you can ask your question, Douglas.
Yes, thank you, Caleb. So, did you highlight the fact that with the GI there are some requirements you need to meet before you get access, or rather, yeah, something of that sort? Because I had to wait for some days before I was given access to my GIE.
Oh, okay.
GEE, I mean. Yes.
Okay, as long as you have, a Google account, then it is possible to, access GEE, as long as you don't want to utilize it for, commercial purposes. And since you are doing it for some academic reason and for some social good, then they will have no problem to, give you a license and give you access. So I don't know.
Okay.
Yeah. So just utilize
Okay, and the limit
of
with the academic account.
I've been using it for quite a while and I've not experienced any, issue. I know the limit exists only, for example, with the Google Drive. I think that's about 15 GB. So maybe if you're downloading images,
Okay.
sending it to your Google Drive, then you'll need to remove those images and put it on your local so that at least you have space on your Google Drive.
Okay. Thank you.
Oh, and then James Kibugu say that, I need to change the maximum date to December. It's January. Let me see. So these are all parameters you can be able to. Yeah, so the minimum date is, I wanted it to start from, the minimum date refers to the starting point, and then the maximum is the last date. So that's why it's
Karen,
particular format.
Karen,
Yes,
it was another, I think code 84.
code 84.
Yes.
Oh,
Just
okay.
up. Yeah, there. Just go
Yeah.
down. The
Okay.
maximum date on this. No,
Code
just
80.
go up.
Over here.
Yes, the maximum date on this.
Oh, okay.
31st January instead of 31st December. Code.
Oh, okay. Okay. These are called placeholders. You see, this is a function. So whatever I'm putting over here can be changed. When you are calling this function, you can be able to change everything that you have written over here. These are just placeholders to guide you. So the real deal will be when you are calling the function over here.
On the other code, okay.
Yeah. So when you're calling it over here, that's where it will now take all of this. But thank you for that observation.
Okay. Thank you.
Yeah, and then Edrina, yes, I don't know about the recording, but the particular notebook. I'll share the notebook, and if you guys also need access to the QGIS project, I will also be able to share it with you guys. I think I answered Nalamutu, even Mr. Ravat. Yeah. So, Charan, I think I've answered most of the questions. This is just a pre-processing step. After this, we will have to, for example, carry out supervised or unsupervised classification and see how we can be able to utilize all these color composites and all these, indices to help us, classify our images better. But due to time, we'll have to leave it there for now.
Yeah, thanks a lot, Caleb. It was a very nice session, and hope people got knowledge about satellite imagery and how to pre-process data. Thanks a lot, guys, for attending this workshop, and really looking forward for the upcoming workshops.
Yeah, sure. Sure, and I will also be available when you guys are going through the challenge to give you, guidelines, and if you need any help, I'll be there and I'll see how we can be able to solve it together, because I'm also learning from you guys. And if you have anything, just let everyone know so that we can learn together. Thank you. Thank you for having me.
Thank you very much, Caleb.
Thank you.
Thank you, Caleb.